Our next speaker is coming from near London, Milton Keynes, and his name is Ali. I was quite intrigued reading his profile. He started out as a medical doctor, but then he realized he's a developer at heart. That's great. We had a talk about that. Maybe he will get into that and see how it happened. Yeah, I will pass you the microphone and good luck with your presentation.
Hello, I'm on, yes. Well, we are trying to sort a few technical issues with the presentation. This is my presentation. So, yeah, that's fine. I've got this. Yeah, when it works. So, I guess I start with just I know that until this gets sorted out, we can basically talk about what I do and my experience, how it's probably relevant to you guys. Do you hear me well? Okay. So, who in this room has developed or consumed a REST API? Thank you. Oh, this is awesome. This is awesome. So basically, today we're going to be talking about a REST API, but that is boring because you know all about it. So there are, when you start building REST API, you might start to get into some kind of trouble, and these troubles usually start. Yeah, thank you. I think we are on. Thank you. Yeah, these. Okay. I think let's play. Oh, PDF is not going to do it. You can't get this. Can you? Right. Yeah, PDF is not going to do it. Yeah, if you can't, okay. Yeah, I mean, if there is only. No, it's a PDF doesn't have all the like bells and whistles and clicks and, you know, like show and not show. So if you can't get this up, it's fine. I think I will do from PDF. But if we can work, but I suppose I can carry on. I mean, it's warm as well. Thank you for your patience. You've been. Sorry. Thank you. So thank you for your patience. It's warm. So appreciate that. So we were talking about REST APIs. REST API has got a number of tenets, right? So one, someone shouts one. Stateless, right? So stateless is one of the tenets, and basically what it says is that you shouldn't use a state, right? No. I mean, it's all about state. It's representational state transfer. So what it says is that you should never ever use a state in a way that you can't process a request just from the request itself. Which means if you have a state on a particular server and this request is going to another server, then you have a problem. So sticky session. So it's not against like sessions or state, it's against sticky sessions. So another one, shout, sorry? Yes, that which is related to that. Caching, right. So caching it's fine, don't worry. I will talk from the PDF. Put the PDF on. Do I get a clicker? So caching. So why do we use caching? Caching is a soft padding, right? So allows your application to respond well. It's like oiling, you know. I don't know, you guys have, you know, it just feels to me like it allows your application to respond gracefully and feels like more smooth. But that's not all, you know. Who has used eTag? So eTag, in addition to allowing for you to do caching, it allows you to do concurrency. It's in the heart of REST. It's been built for distributed computing. So bear that in mind. And I guess we normally do these kind of things. So do I get the clicker? Yeah. So clicker. Right, thank you. Right. No, I don't think this is gonna. Okay, they need to. Okay, if you could go to the slide, the cache. We talked about caching, right? If you go to the slides, I had good, nice pictures ready for you. Unfortunately, yeah, we didn't get to see them. Right. So we talked about caching. The next one is uniform interfaces. So uniform interfaces actually is a big one. So what it talks about is actually, right. Yeah, move on. Move on. Let me see if I can handle it. Yeah. Yeah, it works. Thank you. Right, so, yeah, we talked about stateless, layered architecture. What does layered architecture means? It means you haven't got a clue whether you're talking to the real thing or it's just a proxy. And what it means, that client, you know, is talking to server, right? And right, really doesn't know if it is the real thing. That's how you build API management. That's how. Sorry, I need to speak to more. That's how you build, for example, proxies, caching proxies, security proxies. You know, the ones that don't allow you to use Facebook at work. You know, so that kind of thing. And we talked about caching. So uniform interface is interesting one. So first of all, it talks about the resources and representations. So what it says is that the thing that you are talking to can look different ways, and each one is a representation. So separates representations from the thing that you talk to. So I could go to a customer, which is /API/customer/123, and that might look like a JSON, and then I could change a few things, and that might look like a XML. That might actually return a picture for you, right? So another one is self-descriptive messages. Again, what it says that the message should contain everything that you need to know, or be able to build whatever you need to know based on just that message. Another one is hypermedia. You know, is because it's called hyper, there is a hyper enthusiasm with that. So, which I don't quite share all of it, but it's useful. That's what I can say about it. It's people say it's I don't say it. I heard it somewhere. They say it's like teenage sex, that everyone talks about it, you know, no one has done it, you know, people know that someone else has done it. Anyway, this is, well, actually I took it from big data, but it is a bit bloated. So No one, absolutely no one talks about client server. And that's where I have seen most of the problems happen. So what is client server? It says that the client and server should be separated by a uniform interface and have different concerns, separation of concerns. What does it mean? It means server should be concerned with state and client should be concerned with presentation, right? That's very simple. Nothing can go wrong with that. Well, from experience, it can. So I have been thinking, reading, and basically writing about this for the last 3 years. And I think we can learn a lot from engineers. So let's see how engineers approach their problems, right? So this is, let's pick a problem of the giving DC power to the devices, right? That's an engineering problem. So how this guy is solve this problem? He's put it on the client. He's put it on the device, right? So it's a question of concern, right? So put it in there. Now, this one, which you probably can't see, but it's basically a tablet. It's a different device, connected, and it's giving that response to the server. And then you see this one. It's a mixed concern, solving the problem in two different places. So the same ideas happen for us as well when you design your client and server. So client and server have a boundary, and this boundary is always creates a lot of tension. So now I spent a lot of time, as I said, investigating this kind of thing, and I came up with something that I have followed. And what it means is that the client and server should define and live within their own bounded context. What it means is that neither server nor client is an extension or basically a subordinate of the other one. They have different concerns. They are completely separate. And we're going to basically open it up. So talking about server first, server is not just a thin shell around the data. Server is complex, right? So server has got a lot of complexity, and as all of that is hidden behind people. Why should we hide the complexity behind server's API? Why? Why should no one know about it? So that we can change it without client even knowing about it. So now, client itself can be a server, and basically its responsibility is to bring values. And basically is free to take dependency on URLs, on public domain, and it can keep its state but never masters it. So as I was saying, there is a lot of tension going on, and this tension comes from who? From us, the people who are building these clients and these servers, and result in problems. And these problems we will have a look. So this was, I don't know if you remember, probably you can't see this. So let's look at anti-patterns, right? So the anti-pattern one is Chauvinist Server, right? What is a Chauvinist server? Server that basically the API design takes into account and gets inspiration from server's internal stuff, and what it does is that pushes the thinking to the client, the server mentality to the client. right? This is the most common one. What does it mean? Let's talk about building a shopping basket, right? So shopping basket, always for a customer, and always one, there needs to be one, right? And not always customers have shopping basket, right? And you want to do something useful after they expire. You maybe keep it for like a few hours, and then you want to send an email. So let's implement a shopping basket, right? So shopping basket, you create, okay, basket, customer ID, go and create this basket. And it returns you, okay, I created that. That all looks restful to me, right? And then what I do, I then say, okay, this basket, that's useful. Go and put all this stuff in it. 200, okay, thank you very much. What is wrong with this? The wrong thing is, the basket, which is a temporary thing, the client shouldn't know about it. As far as it's concerned, a customer has a basket, and you just keep stuff to it, and you can check the status of it. So what you do is you say, post customer me, so that you even don't supply the customer ID because you want them to sign in with their own identity token. And then what you do is that, it's done. So the Chauvinist server is as I said, is the most common one, but not the only one. So we have the transparent server, and the transparent server is the one that basically exposes its internals. And so the internal domain of the server makes its way to the API. So let's look at, this is a more kind of complex example. So let's say I'm using an API which has a rate limiting, right? What should I do? And the thing is, I've bought maybe like 5,000 requests or whatever, and an hour. And so this is fine. Most of the time it's fine. But sometimes people coming in and it's just full. What's going to happen? So people coming in, calling it, I call the server, a third-party API, and returns okay. But then I come in, and then there is an error. Why? Because it's rate limited. So let's fix this, right? Let's make this 429, which too many requests. But the client says, I sent you one request. Why do you do this to me? I haven't sent you many. It's just many clients are sending. So that's not a solution. And so what should we do? Let's fix this and get foobar, right? And then when this happens, return 503. Server is unavailable. But really, how does this help? And the problem with this is that, let's imagine these three clients coming in. First one unlucky, second unlucky, third one lucky. Now, that first one wants to do it again because we said try again. So that one again, was unlucky. And the third time, who can guarantee the guy is going to get what he's asking for? So that's not a solution. So we have to change our API. So what we need to do is to put a queue and a limiter and just queue the requests as come in. So we know that whoever asked for it is going to get back the result. But first in, first out. So we say, when you come in, we say, we got your result. We think it's going to take 80 seconds or 80 milliseconds or whatever. And this is where you need to poll for the status of what you asked for. How is that good? Is that good? So everyone now needs to submit the request and keep polling. That's still not good, right? So we need to fix this. And how we're going to fix it is that, as we said, this problem happens only very, like, majority of time doesn't happen. So what should we do? We return, if there is a bandwidth limit, we return 200. And if it's not, then we do that. Now it looks better. So transparent server, as we said, exposes its internal. So your rate limiting already exposed to the outside world. Now we have fixed it. So they don't know basically why all of this is happening. So next one is demanding client. Is there any mobile developer in the room? Yeah, thank you. So you guys could be demanding clients. I don't blame you. You know, we just this is just us trying to work. And as servers, we said two things about servers, now one about the client. So this one is interesting. So the client puts its limitations onto the server signature. What does it mean, right? It means, for example, you say, you know, you need to send me this header. Says, I can't be bothered with headers, you know, honestly. Give me query string, I will put the query string. But reality is query string, if you put query string, then it's a different result. That's a completely different result. Another one is client pushes for consistency with other servers, both in behavior and parameter names. For example, oh, Facebook uses this, you know, this name for this parameter. Why don't you use that? It's a different server. It's completely different server, different API. So that's why the public domain of the API needs to be known by the client very well. And another one is that the server says, client says that I'm not going to use this. This has got too much data for me. Yeah, it's got too much data for you, but it serves other clients as well. And sometimes what you need to do is to create like a summary API as well. This is what we have tried to do now. So the next one, we are almost towards the end. Another two anti-patent. The seaming server. The seaming server is the one that basically tries to define user experience. It's not his job, you know, it's client's responsibility. So examples of that is pagination. Oh, sorry, we can't see this, but this was page 1, this is page 2, right? So what does this mean? Okay, you go to the server and get the pages. That's all, looks really good to me. The problem is for whom? You are talking about mobile or laptop or tablet. They have got different pagination requirements, and that needs to be decided on the client. That's why, if you want to fix it, you say from this to that. And it's up to the client to decide. So now, this is a lot. We have another example. Browser sniffing. I know sometimes we have to do that. But anyway, if you do it, you know, do it on the client. But basically, we had once, you know, people built browser sniffing on the server. And what happened? Guess what happened? We were using Akamai. So the first guy goes in with Firefox, and everyone is Firefox now. So whoever gets in, you know, the response gets cached, and everyone sees the response fully. So that's why if you do this is a client thing. let client handle how it needs to represent it. So the last one, presumptuous client, right? Presumptuous client is the one that basically takes on some responsibility that can't fulfill. Examples of that probably will make it more. So client wants to implement an algorithm that needs to be centralized on the server. For example, VAT, currency exchange, rounding, right? And you have other things, such as giving discounts, those kind of things. Sometimes people do it on the client as well and repeat it on the server because you can't trust things that are coming from client. So they do it again. Well, I know that it's good to do that because we want to give immediate kind of feedback to the user, but it doesn't hurt to just have a quick round trip to the server and just get to, for example, total order number with all the roundings and everything. Another one is just trying to act as an authentication or authorization. Client cannot do that. It's servers. But the caveat is that if you're talking about device, yes, this device is. I think it went. Yeah. So this device basically is a claim. Owning it is a claim, yes. But as a software, you can't have a claim. So the third one is client take control of, for example, caching validation. Says, this is my app is only dealing with a single customer, so I know when I change something. Or you don't know, because that information might have changed by someone else. For that, maybe an admin is making changes. So reality is you can't really do caching validation on the client. So I know you guys are hungry, and I'm too. So basically, that's, as a summary, we talked about Chauvinist Server. Yeah, it's bad. It's just designed from the server's perspective, and the client actually knowing that what, kind of that mentality of, for example, we talked about basket, go and create a basket, come back, it just bleeds into the client. Server exposing this internals. We looked at the case where the rate limiting. Just think about that. We export the rate limiting to the customer, and we actually at the end fixed it. The demanding client is client that wants to change the server's API to fit what it needs, rather than what really server needs to be doing for all different clients. The other one was assuming server trying to define the user experience. And examples, we said browser sniffing, pagination. And the last one was presumptuous client, which client basically tries to take on responsibilities that in no way can fulfill, such as various algorithms, caching validation, those kind of things. So thank you very much. I'm Ali. Don't worry about the surname. And it's my Twitter handle is Ali Osad. And thank you for your patience. I know you are hungry. Thank you very much.